Okay, so my name is Mihai. Welcome to my session. I know it's immediately after lunch. It's going to be tough for you to stay awake, but I promise you this session is going to be very interesting, so I'm going to do my best to keep you awake. In the next 75 minutes, we're going to talk about building elastic autoscalable solutions with Windows Azure. Now, this session is mostly for development teams or development operations teams. Not that much for sysadmins, but yet again, now we have a very blurry line between those jobs, developers and sysadmins. So it's going to be useful for you too if you're a sysadmin. As I said before, my name is Mihai. I'm a Microsoft MVP on Windows Azure. I'm also a Windows Azure internal insider, which allows me to be very close in very close contact to the Microsoft Windows Azure team. And I know a lot about what their roadmap is and what they're doing. I also own a company which I started almost 7 years ago, back home in Romania, very far away from here, by the way. It should have been like 12 hours, but it was like 24 hours to get here because of the weather. But anyway, so we do custom software development, and we do training and consulting for software companies. And during the last 3 years, we've been doing a lot of stuff with Windows Azure. So I have some experience, some real-life experience with 6 or 7 different solutions that we have done. That's why I am here to talk to you about elasticity. Now, just before I go into the main part of the agenda, how many of you guys have some experience with Windows Azure? Okay, so 85% of the room, 85.3. How many of you are developers or DevOps? Excuse me. Okay, 75% approximately. Excellent. Then this talk is really for you. So the main objective of this talk is to differentiate between scalability and elasticity. There are two different words, and in my opinion, they mean two different things. We're going to explain that in a few minutes. Then the most part of the session is going to focus on autoscalability application block, which is autoscaling application block, which is part of the enterprise library, an extension of the enterprise library, which has been developed by the Microsoft Patterns and Practices team for us quite a while ago, and which is not the unique way for you to attain, to get to elasticity, but in my personal opinion, is the best way still today. So this is going to be the main focus on of my session. Now, before we move along, let's differentiate between scalability and elasticity. First of all, if you have some experience with Windows Azure, and you do, then you know that Windows Azure is scalable, right? I mean, it gives us the possibility to add resources or remove resources depending on our needs. Like, for example, let's say you have a cloud service, a web application running in a web role in Windows Azure, and you have very many users. You need to scale. You can add very easily new resources. They're going to be provisioned automatically by Windows Azure. You don't have to take care about creating a virtual machine, installing the system, the operating system, and so on and so forth, or maintaining those. The same goes when you need to scale down. It's going to be very easy to do. Also, another design decision the Microsoft Windows Azure guys took when they created this platform was to give us the possibility to be flexible with costs. I mean, it's one thing that you can add and remove very easily new instances, but what about costs? And if you've been attending Scott Guthrie keynote, or his portion of the keynote, he told us that now the cost model is per minute, as opposed to per hour, as it was before, which is even greater. Now, so Windows Azure is scalable. We have a flexible pricing model, which is good. It's not quite perfect yet. Okay? In order for it to be perfect, we need to improve it just a bit. And one little drawback is that scaling is manual today, scaling in Windows Azure. Now, here is a big debate I've heard with customers of mine or friends of mine in the community, if scaling should be manual based on our decision or not. And my personal opinion is that we should be able, or we should be the person who takes the decision to scale. I wouldn't like Microsoft to create instances for me, because how can Microsoft decide for me when it's going to cost me, okay? So I don't want to do that. I want to still be able to scale based on my decision. The only thing I would like to do is to scale automatically, and this is elasticity. Okay, my personal definition of elasticity is our ability to scale in Windows Azure doing so in an automatic fashion. Okay, we can achieve elasticity today. There are a few options, quite a few, all of them related to the Service Management API. Are you familiar with the Service Management API, any of you? Some, okay. So it's a set of web services, an REST web services, which expose basically the same functionality that you find in the portal. So whatever you can do now in the portal by clicking on a button to trigger some actions, you can do the same thing using the Service Management API. Just call the service from your custom code, and there you go. So all the options to automate scaling are eventually based on the Service Management API. And some of the options are, you can write your own code, like write your own application which targets directly the Service Management API. I think this is the worst solution because you can make a lot of mistakes and you have to maintain that code. A bit better solution is using PowerShell commands. There already are PowerShell commandlets. Are you familiar with those? Anybody? Okay, so you know that you can create automatically or deploy automatically things in a cloud service, for example. And this is a better way to achieve elasticity. You know, write some scripts which can be automated, which can be integrated in your ALM, in your other processes, and they will take care of your instances. There are some other options, like third-party tools. And in the past few months, I've seen some changes here, some improvements. There is one right now. There is a third-party product, let's say, which is available in the Windows Azure store. So if you go in the portal, in the add-ons section, you're going to be able to find it. It's called Metrics Hub. And in the next few months, we're going to see some more changes. Now, the best way, at least in my opinion, to achieve elasticity is using Autoscale application block. And why do I prefer it? Because it's very flexible. I still have to write some code, but it's like 5 lines of code. So I don't risk creating too many bugs in 5 lines of code. And it's very, very, very flexible for me. Now, before going into autoscaling application block, I just want to show you very fast how we can scale with PowerShell. Just a very simple example, very useful for you if you haven't used it before. Just a second to move it right here. Now, I already have an app running. It's in a staging environment in Windows Azure, as you can see it here. And right now, the app is served by one instance. It's not what we want to have in the end, but it's a good starting point. Now, I'm going to run a script. Oh, just before doing that, I should close it. Yeah. Before doing that, I would run a script which will modify the configuration settings of this application. And if you're familiar with deployments in Windows Azure, you know that you have a configuration file. This is it. I'm going to edit it manually. Actually, I already did. The new instance count of this deployment will be 2. Okay, so I edited this file, and now I'm going to run the script with PowerShell, which is going to call a command which is called set Azure deployment, part of the commandlets, if you're familiar with those. And it's going to change the configuration of the Azure deployment. This is what it's going to do. And in a minute or so, we're going to see 2 instances serving our. They're already transitioning. So we already have, or we're going to have in a minute, 2 instances serving our website. This is very, very basic information. And just to take a quick look at our script, here it is. It's just some small things I do before, calling set Azure deployment with the config file that I showed you before here. Okay? This is the config file I've edited before. Now, this is very simple for you to do. And scripts like this can be integrated into your other processes, your operations processes. It's good enough for you if you do that. Okay, so as you can see, the second instance is still being created. It's going to be there. I'm not going to wait for it. We're going to move forward to our main part of our talk, which is autoscaling application block. Now, as I said before, this is part of the Enterprise Library Integration Pack for Windows Azure. This is the downside of it. It has a long name. But the very good side is that it's specifically designed for elasticity. This is the main purpose, actually the single purpose of this library. And since it's developed by the Microsoft Patterns and Practices guys, this means that we are very familiar with how to integrate this library into our projects. And let's see how we can do it. Well, before that, I'm a geek, but I also own a company. So when I talk to my colleagues back home, I like to tell them that whatever the technology is, however cool it is, let's have a business reason before we implement something with it. And before going to that, I just want to mention the business reason. Why should we use auto-scaling application block? Well, this can apply to anything regarding elasticity. So whatever you choose, if you want to be elastic, this is the business reason for it. And the best reason is because you minimize your cost. But let's see how. First of all, you reduce your manual work. If you don't do automatic scaling, it means that you have somebody to do it for you. And if you need to scale 10 times a day, then you need a dedicated resource for that. So it will reduce those costs. It will also reduce the possibility for you to make mistakes. Because if you design it properly, then you test it, you automate it, then it's right there. It's a repeatable thing, it's a repeatable process, less concerns for you. And you can pay exactly for what you need. I mean, not 100% exactly, but close to 100% exactly what you need. Because if you design your rules to scale properly, then your application will just, be there by itself and scale up or down depending on the needs. You don't need to take care about that. And again, as I mentioned, what Scott Guthrie mentioned, that the cost model is per minute, this is yet another improvement. Okay, first of all, when the guys who developed it designed it, they thought about some usage scenarios. They looked at us who are developing Windows Azure applications in the world, and they said, okay, there are at least 2 usage scenarios in respect to scalability. The first of all, the first one, which is the easiest one actually, is when we have predictable load patterns. And I'll give you an example. Let's say we have a line of business application, which is used internally by our company or by our partners. And we know for sure that it's going to be used every day, every working day, between 8 a.m. and 5 p.m. approximately, okay? So this one is very easy to scale. You can configure rules like, I want to have 6 instances running my web role during 8 and 5, and only 2 during 5 and 8 the next day, okay? This is the easiest scenario, and we're going to see it. Now, the not so easy scenario is when you have an application which is facing everybody, public users. You don't know how many users you're going to have. Let's say it's an online shop or an online store. Even if you can predict things like Black Friday or Christmas, you cannot predict everything. So in those situations, it's better for you to have some performance counters that you monitor, and you react on some changes on those performance counters. And auto-scaling application block is doing it for us. Well, we still need to define the rules, but it's very easy for us to do it. Then, when we encounter such a situation, so we need to scale or we need to do something because we have too many users, there are 2 possible reactions we can have. The first of all, and the most obvious one, is to scale. Okay, this is the main purpose of my talk, so you could expect that. But it's not the single possible reaction. And one other as possible reaction is throttling. We may decide, and it's a very good compromise sometimes, not to add resources, which cost us more, but to cut some features. And let's say we have an application which is used by public users and by back-end users, employees in our company. If we have a lot of demand, that means that we have a lot of public users coming in. And we want them to be happy, and maybe our back office users won't be that happy, but the financial guys will be happy. Okay? So we might decide not to scale, but to cut some features, so our back office users won't be able to access those for a few hours, for a day, so on and so forth. It can be a smart choice. And it's very easy for us to do it with auto-scaling application block. And actually, our last demo is going to show exactly that. OK, auto-scaling application block is just a library with a set of XML files you need to somehow include in an application that you build. And here's how it works. First of all, you have, so let me use my mouse. OK, so here's the target application, the application you need to scale or to, I don't know, to throttle maybe. And here are your instances. Well, this application will log some custom metrics, some performance counters, for example. It's very easy for us to log things which come from VMI, Windows Management Infrastructure, like CPU percentage or request queues in IIS, things like that. We're going to log them in a table in Windows, in table storage in Azure. And then we have a separate application which includes the library called Autoscaling Application Block, which will monitor those things in Windows Azure storage, the diagnostic data. And based on the rules we have defined previously in an XML file, eventually, it's going to scale or to take the decision to throttle depending on what we decide, OK? So just to give you a simpler image of the resources involved, we need an application that we build, we make, a very small, simple one, which includes AAB. Now, this application can run both on premises or in Windows Azure. And you might wonder, OK, which is best? Let's think about it for a second. If I run it on premises, then somebody should monitor my monitor, right? Should make sure that the monitor never stops running. So it's another burden for me to take into consideration. If I'm running it in Windows Azure, then it's just going to run. So the best way for you to implement this monitor is to host it in a worker process in Windows Azure. Nevertheless, it can run as a console application on premises. Then you have the rules XML file, which is included in the same solution, the same monitor application. You have diagnostics enabled in your Windows Azure application. So the target app has to store some diagnostics data. And you have, of course, you need table storage and storage in general for that data to be stored and to be read from. Now, this is going to be my first demo on AAB. It's going to be very simple. I'm not going to go into too many details now. I'm just going to show you how it works. And now I have two instances because that's what I said before with the script. Okay, they are finished transitioning. And now let me show you very briefly. I'm not going to show you all the things here in my rule file, but I'm going to show you this rule. And we're going to come back to this file later. Don't worry. But let's look at this rule. And even if you don't know anything about autoscaling application block, I'm sure you can understand what this rule says, right? It says, OK, so the name is scale up. Whenever we have an operand called length q greater than 10, we need to scale up by 1. OK? We're going to monitor, I'm going to show you in a minute, a queue in Windows Azure storage. And whenever this queue has more than 10 messages, we're going to add a new instance to our application. And we have the opposite rule, which is called scale down. And whenever we have less than 5 messages in the same queue, we're going to scale by -1. Now, I'm going to start the monitor, because it's going to take some time to evaluate those rules. And then I'm going to see how many messages I have in the queue. I have 3 messages in the queue, which is less than 5, so it should scale down, if my math is still correct. Sometimes you get to ask yourself questions like, is 3 lower than 5? Because you make a mistake somewhere. And OK, so I'm going to wait like 30 seconds so we can see the autoscaler kicking in and doing its job. Then it's going to take a few minutes to evaluate and react on the rules. We're not going to wait for everything to happen. But we need to see something in a few seconds. Right here. I think it's running. Yeah, it's running. Come on. say something. Yeah, now we're going to have something. Okay. So here are some logs from the autoscaler. For now, there are no configuration changes to be submitted. It's going to need a few minutes for it to realize that we have fewer than 3 messages in the queue, and it needs to scale because we have some configuration parameters which tell it not to react every second. Okay. And the queue I'm talking about is right here. So I'm using a tool you can find in Windows Azure on Codeplex called Azure Storage Explorer. It's a very easy to use tool. And I'm monitoring this queue, which has, as you can see, 3 messages. So less than 5. In less than a minute, it should kick in. We should see a rule being matched, and then some changes to be submitted to the worker, to the web role. Not yet. Just in a second. And then we're going to see one of these instances disappearing from here. Well, we just have to wait a bit because we have some configurations which tell us to. Okay, in the meantime, as you can see, my solution here has 3 different projects. This is the monitor, the autoscaling host. It's just the monitor application that I decided for the purpose of this demo to run from my machine on premises. This can be very easily hosted in a worker role in Windows Azure. In the same solution, I have the target app, which is an ASP.NET app, and the cloud project, which allowed me to deploy it in Windows Azure. And it's taking some time because I have set some configuration. I'm going to show you just a second, but let's see if it's kicked in. Yeah, okay. Can you see that? Yeah, it's big enough. So the rule which says, okay, if you have lower than 3 messages or less than 3 messages in the queue, just delete one instance, was just matched. And we're going to see that changing in here. You can see it's already transitioning. And one of the instances is going to be deleted. Now, it's going to take a few minutes. We're not going to wait for it. We're going to see it later. But one of them is going to disappear. Believe me, I don't have anybody right here below the desk, just creating and deleting instances from Windows Azure. It's doing it for us. OK. Then I will move forward with my presentation. Excuse me. Yeah, please go ahead. Mm-hmm. Very good question. I'm going to repeat it because we recorded. So the question was what's going to happen to existing users, to existing traffic if we delete instances? Well, it's our responsibility, first of all, to make sure that we have at least one instance, or at least 2 instances, actually, running all the time. The purpose of the demo is just to show you the autoscaling application block. So I have minimum 1 instance. But in real life, you should have minimum 2. Because Microsoft SLA, Service Level Agreement, says that you're going to have 99.95% uptime if you have at least 2 instances running your website. So it's going to be your responsibility to make sure that you have that. And I made sure that I have at least 1. You should have 2. It's the same thing. Because I avoided it for the first demo. But I have a rule here which says a minimum and maximum amount of instances that I have to have whatever. Okay, so that's a rule with a top rank, which means that any other rule doesn't have precedence over this one. And we're going to make sure that you have at least 1 and maximum 4 instances all the time. You should just change it to 2, to minimum 2 in a real-life situation. And to make sure that I completely answered your question, what happens to existing traffic so right now we are deleting, or it's already deleted one of the instances. And it goes like this. All existing requests are going to be served. And after that, the machine is going to delete it. And the load balancer in the fabric control, we know that that machine does not exist anymore, and all traffic will not going to be directed to a non-existent machine. So there's no chance that we lose traffic. But we still need to make sure that we have at least 2 machines running. So, yeah.
So this means that when I'm hosting an application on multiple instances, whose responsibility do I have to set up the load balancer myself?
Very good question. I'm going to repeat it again. So whenever I have at least 2 instances, whose responsibility is to configure the load balancer? It's not ours. It's Windows Azure's responsibility. We don't even know that it's there. You just see it working.
And the other question is this scaling block that you showed us, can it be implemented as a system center to 2000, whatever, 10 or 12 agents?
Well, I'm not familiar with system center. So the question is that this auto-scaling application block can be implemented as an agent in System Center 2012. I'm going to ask you back if an agent in System Center is a process, or what is it? Is it a script? What is it? I'm not familiar with this.
I don't think it's a process. It's an agent that feeds into System Center 2012.
Then I don't think so.
You're monitoring the whole thing using System Center
Okay.
2012.
So you're not going to be able to do it with auto-scaling application block, but I'm sure you can do it with PowerShell scripts, which is the PowerShell scripts, you mean?
No, there's a management pack for System Center
Yeah.
that does the auto-scaling, but not with this.
Well, the question was, is this the management pack for Windows Azure which does auto-scaling? No, the management pack which was just announced Monday is to have the same functionality as you have in the Azure portal, but on your private cloud. Okay, so I'm not sure what you're talking about. Please, after the session, come at me. Going back to auto-scaling application block. In order to make it work, we need to define 3 configuration, 3 XML files. First of all, the rules. We've seen just briefly 2 or 3 of them. We're going to see some more. Then we need to define some information about our service. So the cloud service name, the environment we're targeting, staging or production, the storage account, so on and so forth. So we give the monitor access to our resources in the cloud. And then we need to configure the AAB block, auto-scaling application block. We can do it via an app config file or in the code. So this is all you need to do. And to be honest with you, first time you do it, you're going to make mistakes. Because it's just, editing XML files. And you don't have too much IntelliSense, so to speak, there. You're going to be announced that the schema is not valid, but you're going to make a lot of mistakes, believe me. And now let me show you some more code and how the rules are defined, just to make sure I stop the autoscaler. So going back to the file, to the rules XML file, this is the first thing you need to configure. And one of the best things is to always have a constraint rule with the biggest rank. Rank 1 means that this is the biggest rank, which has a minimum and a maximum count. I already told you that. You should always have that. If you don't, you risk to just keep adding instances forever and never delete them or never stopping. And then you can have the so-called reactive rules. The first 2 I mentioned before are looking at some operands, and whenever they pass below or above a certain value, we're going to react by scaling with 1 or -1. And now let me show you those 2 operands which are defined here in the same file. So this operand is actually an average or an aggregate. In my case, it's the last value, but it's an aggregate of this performance counter from VMI during the last 5 minutes for all the instances serving the role. So we're going to see in a minute that the target application is, every 2 minutes storing some data in a table, like the CPU time. And the monitor, in turn, is doing this aggregate. It could be average. I just decided to be last to move very fast. And aggregate on all those counters, on all the machines for the last 5 minutes. And it's very useful, if you think about it, to make an aggregate for a bigger amount of time. You want to avoid scaling up just because for 10 seconds your CPU goes above 80%. Okay? You should be careful about that. So this is the first thing you need to do. Define the rules XML file. Second of all, you need to define this file called services XML. Okay? And which basically just, I don't know if you have very good memory, but this is this is just a demo account, so go ahead and hack it. Here you have to enter your information about the service you're monitoring, the cloud service. And this is the subscription name, a subscription ID, then a certificate which gives me access to that cloud service, and then the role we are monitoring. And then we have very interesting configurations, like I'm going to change it for a bit. Okay? Scaling mode, scale and notify or scale. We have 3 options there. Notify means send an email to an email address we configure. Okay? So maybe you want to be notified and then react manually. I've seen many teams doing as such. So they keep the monitor running. It won't scale. It will just notify you on an SMS, and then you decide to scale or not. Maybe you don't really need to. Okay, I'm going to change it back to scale. And in the same file, you need to define your storage account, the one which holds the table with the performance counters and so on and so forth. I'm not going to bother you with too many details. But another interesting stuff over here is the thing called stabilizer. We have a very smart thing here, designed by the same team, which prevent us from having a yo-yo effect on our instances in the cloud. We want to avoid adding instances, deleting instances, adding instances, so on and so forth every minute. Because we're just going to, our users won't benefit in the end. So this stabilizer says, wait at least 1 minute before you can go up or down, before you can scale. I specifically said 1 minute because I have a demo. We cannot wait 1 hour until it scales. But in real life, you should put like 30 minutes, an hour, something like that. You want to avoid scaling up and then 10 minutes later scaling down. You don't want to do that. And then the third file you need to configure, it's the app config. And don't be scared, I won't go through it as such. We have the smart tool called Enterprise Library Configuration Console, which can be found in NuGet. And here we have the settings for our block. And since it's a 400-level session, I'm going to go a bit, into some details. Sorry if I bother you too much, but I need to explain some of the things here because it's very common that you can make some of the mistakes, which I've done a lot of times initially. So first of all, you need to define the location of the rules and services XML files. This is very easy. But I'm going to focus on this one. I'm going to expand it a bit so you can see it better. Execution lease. I didn't understand in first time I saw it. It's there for us when we decide to host the monitor in a worker role. So in Azure, but not in one instance, but at least 2 instances of the worker role. Why would you do that? Why would you have your monitor served by more than an instance? To make sure it runs continuously. Okay? So if you decide to do that and not have any downtime on your monitor, then you need an execution lease. An execution lease is just a flag in a blob somewhere in the storage, which prevents race conditions, prevents us having, because you're going to have 2 monitors in the end, right? There is the same process running on 2 machines, which means 2 monitors. And you could find yourself in the situation when one monitor meets a rule, starts an action, the second monitor does the same thing, just a race condition. And this execution lease prevents us from having 2 monitors starting the same rule. Okay? You need to set that only if you have the monitor running on 2 different machines. So a worker role with 2 instances in the cloud. Other than that, I don't think we have. Yeah, we have a value here. The rule evaluation rate, it just said 1 minute. It can be a bit higher, of course. Every minute, the rules in my XML file are going to be evaluated, and then depending on what the conclusion is, it's going to react or not. Now, going to my target application, the Windows Azure, this is the application itself, right? It's an ASP.NET application. Here in the web role class in onStart, I made sure that I enabled diagnostics. And for every 2 minutes, I make sure that I send those diagnostics to the cloud, to a table. And also, I collect this performance counter value every 30 seconds from the running machine. So at every 30 seconds, I'm looking at the CPU time, or percentage of the CPU used by this process. And at every 2 minutes, I'm sending that data to the cloud. Where? Well, I have this table called WAD performance counter table. And I have a lot of data up there. It's been there for a few days already, the application, I mean. So we're going to see a lot of entries. And this is the table the monitor is going to monitor, okay? It's going to look for values in here, and then it's going to do an aggregate. Remember, I selected a last value. I could have selected an average value for these values over here, which are going to take some time because, well, the connection is not very, very fast. Just a second. Nevertheless, we're going to see some. Oh, maybe if I filter it, it's going to move faster. Yeah, we're going to see some values for this performance counter, the CPU time, in a minute or so. Okay, now going back to the rules XML file, because I want to show you some different features, like being able to also scale up. I only scaled down from here. And also be able to do a different thing called throttling. This is going to be my second part of the demo, actually. So first of all, I want to scale up. I want to make sure that I add 1 machine using autoscaling application block. For that, I need to add messages in the queue. The simplest way for me to make sure that this rule is going to be met. I need to have, I think, at least or over 10 messages in the queue. And this is the rule, scale up. Okay, I'm going to start the monitor again. I'm running it in debug so we can see the output here, the trace, the debug information. And in a few minutes, we're going to see another instance being created. But before we see that, let me see if Windows Azure Storage Explorer is responding, which is not. Oh, yeah, it is. So going back to the logs, this is the table where we store information like, this is the only counter I'm monitoring, actually, processor time. And you see it's not being used that much. But we're going to make sure that the application triggers the CPU to go to 100% for my next demo. And then we're going to see some changes, some very interesting changes here. Now, let me see if our autoscaler met some rules. Not yet. It's too early for that. Just so you know, it says here rule match. It's referring to the top ranking rule, which says minimum 1, maximum 4. So this is just a false message here. I'm not looking for that in the trace. Okay. We're going to see it kicking in. Let's see. Okay, in the meantime, I'm going to explain some of the stuff needed for the second part of my demo. So the second part of my demo is going to allow me to throttle, so not to scale, not to add instances, but to cut some features from my web app. As I said before, it's one of the decisions I can take. It can be a good compromise. And I'm going to show you one of the pages from the app, the target app. So we're in default ASPX CS file. Okay, and here on pre-render complete, we have this condition, this switch, which is looking for a setting. I'm going to show you the setting immediately. And we have two options. If the setting is high activity, then we're going to disable two buttons. This is just cutting some features out. It's very easy to do, right? And of course, a text is going to be entered on the page so we can see where we are. And the other setting, which is normal or not high activity, it will enable those buttons. Now, I'm referring to a setting, which you can see over here. It comes from the Windows Azure settings, and I'm going to show it to you. So I'm opening the settings area of the cloud project, and here it is. It's called throttling mode, and its initial value is normal. So it's the starting value. Whenever the CPU goes beyond, I think 80%, 85%, I don't remember the setting, but we're going to kick it to 100 just to make sure. This setting is going to be changed. So the monitor, instead of creating new instances, is going to change this setting. And the target application continuously, on pre-render complete, as you can see, monitors this setting and decides what to do. So very easy to do, very easy thing. Let's see if we are lucky and some of the conditions were met. It has been submitted. So yeah, we have two instances just being created, the second one. I want to focus, though, on this log over here, because this is another very important information. So before this log, a few minutes ago maybe, a rule to scale was met. So it triggered scaling on my web role in Windows Azure. And then the same rule was met again, because I still have 11 messages in the queue. And the rule says whenever you have at least 10 messages, you should scale up. But since the deployment is not in the running state, it's transitioning because it's just scaling, it's not going to submit those changes. This is already embedded in the autoscaling application block. I didn't have to do anything about it to prevent crazy situations. It's just there. It's just a fail-safe situation, okay? So that's why the rule is met, but nothing is submitting to the cloud because, well, it's transitioning. And then I'm going to make sure that I remove some of the messages. So we're not going to scale up again. And then I'm going to stop this monitor. I'm going to restart it again after I change the rules XML file to go ahead and show you the second part of this demo. And just to be extra safe, I'm going to comment these rules and uncomment some of the rules I didn't show you before. Oops. Now, as you can see from the comment here, these rules over here do not scale but change the setting. These are the rules I talked to you about a few minutes ago. Whenever we have the CPU beyond 50%, above 50%, no, below, this is below 50%, we're going to set the throttling mode to normal. And whenever it's greater than 50%, we're going to set the same setting to high activity. Very easy. Now I'm going to let it cool down. Actually, I can go ahead. Now, when I'm going to click this button, the CPU is going to go to 100%. Okay, then we're going to have to wait for a few minutes, and we're going to see that throttling active, and these two buttons disabled. Okay. Before doing that, I want to make sure that my XML file is rewritten. So I'm rebuilding everything because I changed it. It happened to me a lot of times. During a session, actually, I did everything right here, but it still had the old file. And it's like, I don't want to do that. Now I'm going to start the monitor again. And now we commented the previous rules. We only have the settings rules, the ones which change the setting. And if we look here, I'm going to trigger the high utilization to on, which is going to start logging some performance count, the same performance counter with 100 value in the table storage. I love doing this session, but you have a lot of delays between things you can see. So sorry about that, but we're going to move on very quickly. I don't know why we still have two instances running. We should have. Okay, maybe the other rule was kicked in before I stopped the autoscaler. It can happen. Now I'm going to have, and because the CPU is at 100%, you can see the page is not very responsive. So it's going to refresh and say that high utilization is on, but it's taking some time. Let me go ahead, which is good. This is what I want to do. Let me. Now, there's not a problem with the internet connection. It's only a problem with the CPU on that machine because it's at 100%. So if you please find some time for us. Okay, meanwhile, the monitor is running, but it has some delays, so we're safe with that. Not going to find ourselves in a crazy situation. Yeah, it's on. Okay. This means CPU 100%, which is greater than 50. I just want to make sure. And we're going to see some changes. Let me scroll up. No, we don't have any changes submitted yet. We're going to see some changes in the monitor immediately. If not, if it's going to take us too long, I don't want to spend too much time on this, I'm going to manually set or change this setting from the portal. It's going to be the same. Please, go ahead.
So the CPU counters are stored in read in table storage. Are the queue counts also stored in table storage, or are those read directly by the monitor?
The key accounts?
The queue account.
The queue. Okay, so the question was, the performance counter monitor is stored in a table storage, and this is the table it's stored in. The queue length is not stored here. The queue is simply, we just monitor the queue. And let me show that to you whenever I can grab this one. So this operand called length queue just monitors this resource. It's the name of a queue from my storage account. It's a bit confusing at the beginning because the monitor actually monitors different resources, but they are there. So whenever you have some questions, go ahead and ask. Yeah, please.
What types of things can be we have performance counters, we have storage queues, what else?
So the question was, what can we monitor, actually? Anything from WMI, anything from, the things from the storage accounts, like, messages in the queue or records in the table. Let me think if you can monitor.
Would it work with service bus
Yes, of course, the same thing. It won't work, for example, with number of records in a table in SQL Azure. But you can, define your custom operand in your app to store that value in the same place. Still no changes. It takes us some time. It's at least 2 minutes for the changes to be submitted. Okay, so if you still have questions, please go ahead. Yeah.
So does this work for more than one service?
For more than one cloud service, you mean?
Yeah. So
Yeah.
if there's a bunch of applications, you can all deploy it into one.
Yeah, the question is, does this work for more than one app? For more than one target app? The answer is yes. You can have a single monitor with multiple autoscaler instances. And let me show you that. I was actually planning to show that later, but it's fine right now because it takes us some time to show everything. This is the application we need to do. We need to build. This is the only class we need to write code in, and this is the whole code we need to write. Instantiate autoscaler, start it, and stop it whenever we like. And for us to monitor more than one application, we need multiple instances of this class. And in my demo here, this autoscaler is configured from the web config. But you can do the same thing from, it's debugging. You can do the same thing from code. Okay. Thanks for being very proactive and helping me with the demo.
Any limitations to the number of services?
I don't know about it. So the question was, any limitations to the number of target apps that we can monitor? I don't know about any limitation. Please. I didn't think about it yet. So the question was, will you be able to see my samples? Yes, I'm going to make sure that they're on my blog. I'm going to show you at the end of the session a link to my blog, and I'm going to put them there. Anyway, what I did here is based on the labs already written for us by the Pythons and practices team. I just completed those labs and then changed a few things. So you're going to be close to what I've done if you do the same labs. In the resources on my slide. So you're going to see a link on my slides. In the meantime, the monitor has done its job, and configuration changes were submitted, which is what we were aiming for. Excellent. And if you look in the configure section of our portal, we can see that it's in progress. Actually, it's changing this value. As you can see, it's disabled here. This is the old value. It's being changed right now. It's going to change to high availability. And then the application is going to refresh and disable those buttons immediately. It's not done yet. OK, so the throttling mode is high activity. I didn't make it. There's nobody here underneath. Yeah, and this is the application. Very cool, right? This is a very good compromise. At least I was surprised. Why would I do that? But then, yeah, it's a good compromise if you think about it. If you have fixed budget on your spending on Azure instances, why not? OK, so let me think again what I was going to show you. Yeah, I'm going to make sure that everything goes back to the initial state. So I'm going to trigger the utilization to off whenever I can. Yeah. OK. It's going to take some time because the CPU is very busy. So we've been using this application block in some projects that we did a few years ago. And it's just there. You don't have to, take care about anything. Once you define your rules properly and you tested it, of course, then it's working by itself. Okay, I'm going to move away from the demo for now. We're going to get back and see the utilization back to off, and move with my presentation forward. So the question the gentleman asked is already answered. What about if I have multiple applications? Yes, very possible. But a related question is, what if I have the same application in 2 different data centers? And maybe you ask yourself, why would I have that? So this is just a side note from my session. You would like to have the same application in 2 different data centers if you want an extra failover policy just in case the data center falls down, which can happen in case of, thunderstorms or whatever. So if you are in this situation when you have everything duplicated in 2 different data centers or more, you just treat those instances, those cloud services, as 2 different applications. You just need to orchestrate, to balance the traffic evenly between those, which is very easy to do with Traffic Manager, if you're familiar with it. Okay. Now, common mistakes. My company did all of those. So there are good chances that if you don't know about it, you're going to do them also. The biggest mistake I've seen is performing an autoscale while doing a deployment, an upgrade. So you have your DevOps team shipping out version ++, the new version of the application. You have version 1 in production. Here comes version 2. And you have, let's say you have 6 instances running your app. And do you know about update domains? This is another side note. If you don't, when you have multiple instances in the cloud, those instances will be in different logical areas called update domains. So whenever you do an update, the Fabric controller will do it sequentially to make sure that as few instances as possible are down while the upgrade is being performed. Okay, so because of that, let's say you are just doing the upgrade. You have 2 instances with the new version, version 2, and 4 instances still with version number 1. And just right there, the autoscaler kicks in. First question. Let's say it's saying Fabric controller to scale by 1, so to add a new instance. We're going to have the 7th instance, this is for sure. The first question is, which version of the software will the 7th instance have? This is a good thing. We're going to have the new version. Okay, so this is a good surprise for me. I just talked yesterday to the person from the Fabric controller team which manages that. And I wasn't sure, but now I am. The second question is, would I have any impact, any bad outcome? Yes. The whole upgrade is going to take much longer. Because what happens is the guys from Microsoft make sure that no 2 upgrades or update commands are being done in parallel. So whenever the second one comes, the first one is being stopped. And this means a lot of delays. You can never get in an invalid situation if you do this mistake. It's just going to take longer for the upgrade to be performed. And you want to avoid that. And now another side note, another thing which DevOps teams do. Let's say you have 6 instances, you're going to ship the new version, and you want to make sure that during the upgrade, you still have at least 6 instances available. One way to do that is temporarily to add 1 instance, so we have 7 instances, and perform the upgrade, and after the upgrade is done, delete the extra instance. And this way you make sure that all the time you have at least 6 instances responding. Now what happens if your DevOps team has that, creates the 7th instance, and then the autoscaler comes in? So it can be pretty messy. Again, you won't be in an invalid state, but it's going to take much longer. So the best takeaway for this is whenever you do an upgrade, stop the autoscaler. It doesn't do anything useful anyway during an upgrade. So just stop it, make sure you stop it. So you have to embed this into your procedures. Another common mistake is forget about the limits, minimum and maximum. This is obvious. If you just keep adding instances, it will cost us a lot, and our boss won't be very happy. Just make sure you have the maximum and minimum limits set. And minimum should be 2. In my demo is 1 because it's a demo, but in real life should be 2. Another big mistake is no opposite rule. Whenever you have a rule which says when the CPU goes above 80%, I want to scale up, I should make sure that I have the opposite rule which would say, for example, whenever the CPU goes below 40%, I should scale down. If I don't do that, I will scale up but never scale down again. Okay, so make sure you have the opposite rules. Another not so big mistake, but still a mistake, is hosting the monitor on premises. The downside, so the single negative outcome is that maybe the monitor will stop working because somebody just performed an update on that server, forgot about it, or the server crashed or whatever. It's not a huge mistake, but the best way is to have your monitor in a worker role, and it's enough for you to have just one instance in the worker role. I don't see too many reasons for you to have the monitor in 2 different instances, because the worst case scenario which would happen with just one instance running the monitor is you're going to have a downtime for 10, 12 minutes. This is the worst case scenario, which is good enough for the monitor. Another mistake is forgetting to have a stabilizer. Okay, so if you don't, the initial configurations for the stabilizer is 20 minutes. You can change that to make it bigger, but not lower than that. You want to avoid just going up and down every minute with your instances. Okay, so we can move along with our session towards the end, just to sum up. So I had 2 main purposes. First, define scalability and elasticity, and explicitly the difference between those, and then talk as much as possible about the autoscaling application block, which in my opinion still remains the current best way to achieve elasticity with Windows Azure. And of course, all of these are referred to a cloud service, so to a platform as a service offering in Windows Azure. I didn't talk about scaling virtual machines, so infrastructure as a service. It is possible with PowerShell scripts, but not with autoscaling application blocks, so it's referring to cloud services, actually. Now, just before I close, let's go ahead and see our application, which came back to off, which is what we wanted. It's OK. I can now shut down my autoscaler because it's just here for the demo. And this is, I think, the best takeaway. When we autoscale, then and only then we pay exactly what we need. And we can achieve autoscaling in a few ways, one of them being using autoscaling application block, or PowerShell scripts, or whatever, or third-party tools. Why not? Now, if you still have some questions, please, we still have time, like 10 minutes almost. Yeah, go ahead.
So there's no pause functionality or anything like that?
Pause?
Yeah.
I don't know anything about it. We can search for a pause. I don't think there is. So you would like something like scalar.pause, right?
Yeah, when you've got an application to do an deployment,
No, so you would have to do it manually.
you can stop it and then start it again.
Yeah, stop and start again. Yeah, of course. You can have a web config setting which says, OK, stop, restart, something like that. Yeah. Any other questions? OK, don't forget about the feedbacks. But before that, yeah, related content. There are some still remaining some Windows Azure talks related to what I've talked to you about today. Windows Azure internals, I'm going to be there. It's going to be Markus Inovich. I'm going to make sure I'm there. Then patterns and practices, WAD B201, and more about PowerShell connects. And of course, you're going to find me at the booth. I think I'm today, starting at 3. So you know about the Tech Expo, the Micro Solution Experience area. There we have 3 Windows Azure booths. You can come and ask us more questions about Windows Azure. Specific to this session, you're gonna get the PowerPoints. And one of the links is exactly the hands-on labs I used to make this demo work. I changed it a bit, but you're gonna get very close. And because I promised you, I'm gonna make sure that I'm gonna put the the resources on my blog, which is here. I'm going to paste the link in the PowerPoint and make sure that the organizers get the newest version of the PowerPoint. So it's going to be there. Okay. And don't forget about the feedbacks. You have a chance to win very cool stuff, including an Xbox and other smaller things. Thank you for joining me.